ch114, chapter 24, polyphase systems, problem number 32. Again, we have a Y-connected generator to a Y-connected load, and it says find the total watts, volt amperes reactive, volt amperes, and FP of the three-phase system. So watts is going to be the real power, volt amperes reactive is going to be Q, reactive power, volt amperes is going to be S. That's the total power. So you could see that this is purely resistive. Um, the voltage phase is going to be 120 volts, which is what it is. And then the current, since it's Y connected, is going to be, the current of the phase is going to be V phase divided by V load, or Z of the load, which is 20 ohms. That's going to be 6 amps. So there's 6 amps flowing through this resistor here. The total the total power is going to be 3I squared times R, which ends up being 2,160 watts. The total reactive power is going to be 0 because there's no reactive components in here. And ST is found through this formula here. It's P squared plus Q squared, square root of both of them. In this case, since Q is 0, it's equal to PT. And then FP is PT over ST, which is 2160 divided by 21 VA equals unity. It's a 1 unity power factor. Problem 42. A balanced three-phase Y-connected load has a line voltage of 208 and a power consumption of 1200 watts, leading power factor of 0.6. Find the impedance of each phase. So first thing, you have PT, you use this formula, and then you're looking for the line current. So when you solve for the line current, you get 5.55 amps. And then for Y connected, the V phase equals V line divided by the square root of 3, which equals that. And then theta equals inverse cosine of 0.6 because you're given the power factor. This is power factor equals cosine of theta. So you just take the inverse cosine of both sides. Theta equals inverse cosine of 0.6. It's 53.13 degrees leading. So you needed that for your current phase angle. So this is the current phase angle. You put that in here. You found out what the current was in here. And then you take your impedance per phase is V phase divided by I phase, which ends up equaling that. And then what they did was they broke it from the polar form into the rectangular form to find that this is the R value, and then this is the capacitive value that would be in series with it. It would look something like this up above, only the resistor would be 12.98, and then there would be a capacitor in series with each one of these, and it would be this would be the capacitive reactance.